So today's lesson was on factoring by the greatest common factor, and this is how we're going to start the part of the unit where we're dividing polynomials. So first thing you need to know is that when we ask you to factor, what we're saying is that we want you to find all of the factors of a number or an expression, and we want you to write those as a product. So the definition, so that you recognize, is that to factor a number or expression means to write the number or expressions as a product of its factors. So to give you an example, that helps you to understand this definition, I want to show you first with numbers. And I took the numbers 24 and 36. And I want to factor these out. The way I'm going to do that is by using a T-chart. And I'm going to list all of the factors. So I know that 1 times 24 gives me 24. So these are factors, and this is the product of those factors. So 1 times 24 is 24. 2 times 12. 3 times 8. 4 times 6. And that's it. Okay, so once you repeat a factor, you're done. For 36, the factors are 1 and 36, so the product of these two factors gives you 36. 2 and 18, the product of those two factors give you 36, and hopefully you get the point. So 3 and 12, 4 and 9, and 6 and 6. So we're done with the factors. So when I ask you for the greatest common factor, you're looking for the largest number that both of these lists have in common, both of these lists of factors. And that number that you're looking for is 12. So when I ask for the greatest common factor of, let's say, just a number, the greatest common factor for these two would be 12. So to start off, I have this example, and I want you to know that I'm taking this from the activities in our book. So I'm looking at page 386, and what I'm going to go over with you comes from this page. So the first example, I want to first determine what the greatest common factor of all of the terms are for this polynomial. I want to focus on the numbers first. So the greatest common factor, number-wise, is the number that will go into 6 and into 2 and into 8. So the largest common factor, number-wise, is going to be a 2. 2 will go into 6, 2 will go into itself, 2 will go into negative 8. Now for the exponents, I have x to the third, x to the second, and x. So I can't fit x squared into x, and I can't fit x squared or cubed into x. So the largest exponent that I have would be to the first power that could go into every single one of these. So 2x is my greatest common factor. So now what I'm going to do is I'm going to write these as each term as a product of the greatest common factor and another factor. So here's how we're going to do this. I take my greatest common factor and I'm going to multiply it to some term, but I've got to get this right here, that term. So I'm working kind of backwards. So 2 times what gives me 6, and that number is 3. Remember, these two terms have to multiply to get you 6x to the third. So 3 times 2 is 6. X to the first times x to the second gives me x to the third. So 2x times 3x squared gives me 6x to the third. Plus, again, I take my greatest common factor, and 2 times 1 gives me 2. X times x will give me x squared. Now I'm going to subtract. I take my greatest common factor again, and 2 times 4 gives me 8. X times 1 gives me x, so I can just close that off. Now we're going to go ahead and take out the 2x, and that would allow us to use the distributive property to factor out the greatest common factor. So for example, notice that 2x is being distributed to every single one of these, so I'm going to bring that out. So we're working backwards. So 2x, when I distribute that, I would be distributing it to this number to get 6x to the third. So what's left over is 3x squared. And when you're factoring out, what you're really doing is taking each of these terms and dividing by that 2x. So that's why we found that greatest common factor. Next term, when I factor out the 2x, I'm left with 1x. When I factor out for the third term the 2x, I'm left with minus 4. And so when I ask you to factor using the greatest common factor, this will be your result. This is the answer. Here's another example. So again, look at your numbers first. So my greatest common factor will be, for the numbers, a 12. Now variable-wise, I have y to the first and then no y at all. So my greatest common factor is just 12. So I'm going to go ahead and write these as a product. So the greatest common factor, 12, times 3 will give me 36. And then y will come down. So 12 times 3y goes back to 36y. Minus, and now I've got to rewrite 24 using the greatest common factor. So we're going to write it as a product of factors. So 12 times 2 gives you 24. Okay? Now I'm going to pull that 12 out. So I have 12 times, and I have 3y that will go inside the parentheses, minus 2. So this is the answer when you factor using the greatest common factor. For this example, let's go ahead and again find the greatest common factor. So the greatest common factor number will be 2. Now look at these terms. They have x to the 5th, x to the 3rd, and x to the 2nd. So we have to look for the exponent that will go into each one of these, and that's going to be x to the 2nd. Okay? So let's go ahead and do what we did earlier. So we have 2x squared times 2 times 2 will give you 4. X squared times x to the 3rd will give me x to the 5th. Remember your laws of exponents. So same base, you add your exponents when you multiply. So 2 plus 3 is 5. Okay, minus greatest common factor times 2 times 3 is 6. X squared times x will give you x to the 3rd. Remember there's a 1 here, so 1 plus 2 is 3. Plus 2x squared times 2 times 5 is 10. X squared times 1 is x squared, so we're done there. Now let's go ahead and pull that out. So we have 2x squared times, and what we have left over right here is 2x to the 3rd. What we have left over for the second term is minus 3x. And what we have left over in the third term will be just a 5. So now you have factored this problem using greatest common factor. So the greatest common factor, the number would be 5. Now this has a t squared, this has a t to the first, but this one doesn't have a t, so we can't take out a variable. So our greatest common factor will just be 5. Okay? So let's write these as products of factors. So 5 times 3 gives you 15, and then t squared comes down. So 5 times 3t squared gives you 15t squared. Plus, there's your greatest common factor again. 5 times 2 gives you 10, times t gives you 10t. Minus, there's your greatest common factor. 5 times 1 gives you 5, so we'll just put a 1 there. We're going to take that 5, that greatest common factor, out, and here's what we're left with. So when I divide this out, I'm left with 3t squared. In the next term, when I divide 5 out, right, because my greatest common factor is 5, I'm going to have 2t left over. And when I divide this 5 out, I'm going to be left with a negative 1. And so now you have factored this problem. Okay, the greatest common factor, well, it looks like it'll be 9, because 9 can actually go into itself, and 9 can go into 36 as well. But we don't have a variable for 9, so we have to make sure that we don't put a variable here. So we're going to write these again as a product of factors. So we have 9 times 4 will give you 36, and the x will come down. Plus, we have 9 times 1 will give you 9, so the 1 goes here. So now we can pull out that greatest common factor, and when we divide it out, we're left with 4x. Plus And when I divide this out, we're left with 1. So now we have factored this polynomial by using the greatest common factor. So we have 6, 12, and 18. And it looks like the greatest common factor for the number will be 6. The greatest common factor for the exponents will be x, because that's the largest exponent that'll go into all of these. Or I guess you're seeing it as the smallest exponent, I guess. So 6x is our greatest common factor. So here we go. So 6x times, 6 times 1 is 6. X to the third gives you x to the fourth, because 3 plus 1 is 4. Plus 6x again, times 6 times 2 is 12. X times x is x squared, and remember this is a 1, this is a 1. So 1 plus 1 is 2. All right, minus 6x times 6 times 3 is 18, so 3 goes here. X times 1 is x, so that's all we'll do there. Now we're going to pull that greatest common factor out, and we're left with 1x to the third plus 2x minus 3, and you're done. So the greatest common factor for the number is going to be 25. It'll go into itself, into 250, and into 125. And into the third power is what we're going to use for the exponent, because it'll go into itself, into the third, and into the fifth, and into the sixth. So when we factor it out, when we write it as a product of factors, it'll look like this: 25 into the third times 5 into the third plus 25 into the third times 10 into the second. Remember to check yourself. 3 plus 2 is 5. Plus, and then 25 into the third times 1, because 1 times 25 into the third gives us that entire expression, 25 into the third. So now let's factor it out. And we're left with 5 into the third plus 10n squared plus 1. And now you're done. The greatest common factor here will be 3 and just x. So we have 3x times x squared plus 3x times 3x plus 3x times just 2. And you can double check by multiplying these, and you should get these values right back. So now we're going to pull that greatest common factor out, and we get 3x times x squared plus 3x plus 2. And you're done. So the greatest common factor here, let's see, we have 2/3, 1/3, and 4/3. So our greatest common factor in all of these is 1/3, because I have 2 1/3s here, 1 1/3 here, and 4 1/3s here. Okay, and then I have y squared, y to the third, and y to the fourth, and so therefore I'm going to have y to the second as my greatest common factor for my variable. So we're going to take that greatest common factor, and we're going to write products of the factors. So 1/3 times 2 will give you 2/3. So we just put a 2 here. Y squared times y squared gives me y to the fourth. Plus 1/3 y squared, so your greatest common factor. 1/3 times 1 is 1/3. Y squared times y will give you y to the third. Minus our greatest common factor times 1/3 times 4 gives me 4/3. Y squared times 1 gives me y squared, so I'm done there. I'm going to pull that greatest common factor out, and I have 1/3 y squared times 2y squared plus 1y minus 4. And now that problem is done. Okay, again, the greatest common factor. Let's look at the numbers. We have 4, 12, 8, and 4. So it looks like my greatest common number will be 4. Greatest common factor for the numbers is 4. Now let's look at these one at a time. Let's look at x squared. This is x to the first. X squared, x. So it looks like my greatest common factor will have to use an x to the first power. Now we have y squared, y squared, y to the first, and y to the first. So we also are going to include a y. Okay, let's start writing this as a product of factors. So we have 4xy times, 4 times 1 is 4. X times x would give you x squared, and y times y would give you y squared. Plus 4xy times 4 times 3 is 12. X times 1 is x, so I'm just going to leave that. Y times y is y squared. So if you wanted to put 3 times 1 times y, you could, but I knew that 1 times 3 is just 3, so that's why I didn't put it. Okay, minus 4xy times 4 times 2 is 8. X times x is x squared, and y times 1 is y. And so now I can just close that up. Minus, and then 4xy. So 4 times 1 is 1, x times 1 is 1, and y times 1 is 1. So I'm just multiplying 4xy by 1, because that's what I would end up with there. Okay, let's take out that greatest common factor, and we're left with 1xy plus 3y minus 2x minus 1. And now you're done.